reminders, what's going on next week? Prototypes. And structural analysis document, both of those things, that sounds so pro. These guys are impressed, I'm sure. Those are both on Thursday, right? Yeah, okay. That's it. That's all my updates. I'm gonna give John and Tom the floor from BPA. And thanks for coming, guys. Appreciate it. So, yeah, absolutely.
Well, my name is John. I started out at Clark College, finished my 2-year program there, moved over to Portland State, finished up electrical engineering. And then, have you guys ever heard of BPA? Anybody here? Bonneville Power? Okay. So Bonneville Power was created by the president in the 1937 to market and transmit and sell bulk electric power. So it's run through the government. So all the electricity that's used in Portland, Seattle, as far west as Wyoming, from Canada down to Northern California, all come from BPA. So all the hydroelectric dams, all the windmills you see up and down the Columbia River Gorge, all the new solar farms going up, that all connects to us. We run about 350 substations and tens of thousands of lines of transmission towers all over the place. We even have a direct line straight to Los Angeles. There's like a consumer of electricity. A lot of it comes from here in Canada because of the hydroelectric system. So that's where we came about. We are part of the Department of Energy now. We have about 5,000 employees, large numbers of electricians, craftsmen, engineers. Got a list here. I forgot to hand this out. I'll just start it here and you can send it around. But this is a flyer that kind of shows some information about the federal jobs. We hire two different types of people. We hire federal employees, which typically work there until they die. People like working for the government. People like working at BPA. I'm not joking about that. They work right up to the end. We also hire contractors. You know I'm right.
Yeah.
Sometimes it's easier to get a contract job before a federal job. Those people typically stay a long time also and eventually move over to a federal job. So the reason why I'm here is we haven't hired a technician in, I don't even know how long, 10, 15 years. Tom came in on a program, a smart person came to this school like 20 years ago and hired like an entire class. Brilliant. And I believe they did it again 2 years later at Clackamas Community College. And those people still work for BPA. They've been here a long time. Like I said, people don't leave. But we need more. We are in desperate need of electricians, craftsmen, technicians, and engineers, really. People to help design substations, everything from high voltage outdoor stuff, big giant transformers the size of a house, telecommunications, all that stuff. There's actually a list on here of all the different ones, but it doesn't specifically spell out substation design for technicians. It really should. But anyway, that's how BPA came about. And we have offices in Vancouver, we have offices in Portland, and then we have smaller offices spread out all over. We have some in California, Wyoming, Canada. They're all over the place. Those people do maintenance. But anyways, with tens of thousands of miles of transmission lines and 300 plus substations, we've been building these for more than 85 years. It's kind of like painting a bridge. When you get done painting a bridge, you go back to the starting place and you start painting it again because it took you that long to paint it. We are constantly updating. We're still pulling equipment out that's been in service since the 50s.
Yeah.
There's some old stuff out there. You wouldn't believe what keeps your lights on. This stuff. Yeah, I heard there was a transformer once. I don't know where we got it. We must have like taken it from some other country, but it literally still had a swastika on it. The stuff stays in service for a really, really long time. And it's a really cool thing that we get to do to build out equipment that serves the needs of the Pacific Northwest for that long. When you get done doing a design project, it's not, a chip that's going to go into the next Ford and be tossed out in 3 years. You're going to build a substation that brings clean, renewable power to the Northwest for longer than you're going to be around. I guarantee you that. It's very, very cool. The people that come to BPA and stay at BPA like what they do. They want to be a steward of the Northwest's natural resources. We do a ton of work with habitat restoration for even just salmon, but all sorts of things. It's really, really neat. So he actually does a lot of the work. I want to get out of his way and let him talk so he can tell you. Do you have any questions about hiring? I understand, Troy, you can put them in touch with me and we can set up interviews. We're hiring now. We're not gonna stop hiring. So if you're just getting into your program, keep us in mind for later. Yeah.
Is that entry level?
Oh, yeah. That's what we're looking for. There's not very many people that can come into a job interview and know how to do, 500 kV line design. Turns out we're like the only people that do that. So not very many people come in knowing what we do. We also operate a communication system literally from the 70s that no one graduated from class knows how to work with. Because they don't teach that anymore. And a lot of electronics went away a while ago. No, we're looking for entry level.
Yeah, and John said that, the stuff from the 40s is still working, but a lot of times stuff that's 10 years old is now, as you know, obsolete. So we often are going in and replacing equipment that's 5-10 years old because the company that made it doesn't support it, or they can't find the parts for it because that semiconductor industry isn't filling that void, so it's this constantly, just everything is constantly being updated and from the beginning until today. I mean, it's amazing how much equipment is just worthless and it costs us so much money to engineer it, install it, wire it, all this stuff, and now it has to go away and you're like, God, it's still shiny and new, like how did this happen? But so yeah, for me, like a little of my history was I was working as an electrician and I didn't really like crawling through crawl spaces and attics and stuff like that. And I saw a lot of people in the industry that had higher skilled jobs that were working on a laptop, say in the crawl space. I'd be dragging wires behind them and, trying to get around them and stuff. And they're like programming either HVAC systems or, light touch systems where you can turn on a light or open a garage door or whatever from any keypad in the house. And I was like, oh, this looks like a way better idea. And so I came from Jackson Hole, Wyoming, and left my ski town to come to Portland to start this program. And the first day, the instructor tried to scare everybody out of the class. Like it was like, if you're not into this, you better go and blah, blah, blah. So it was really scary because I'd really committed a lot to getting here. And then we were sort of board-based semi-electronic. So we were functioning as our career path was to go from here to Fujitsu and work on semiconductor machines that make silicone chips and the whole thing. And then that sort of just crumbled. Like they went out of business and Intel and everybody cut back all their staff. And I guess that's one thing I'd like to point out with Bonneville is that it's kind of a recession-proof job. Like once you get there, you're in and no one's going to come and fire you. There's not going to be a big layoff. Like it's really a solid job. So it's really, if you're building a family or whatever, it's a really solid foundation to have. And you can make mistakes that probably in private industry, you might get fired for, and there's a lot of like, well, you learn from that kind of thing. So it's really comfortable and relaxed in that method. And so primarily what we started doing when we got to Bonneville was we were redrawing old drawings that were they were more or less on microfiche and they were never put into CAD system. And so we make a lot of CAD drawings from scratch, or we constantly updating old drawings. So CAD skills are going to be like really like 90% of the entry level job is to be sort of processing documents and doing CAD and sort of helping the engineers. So you kind of work hand in hand with an engineer and they'll hand you prints that are all marked up or partially marked up, and you have to like, they'll just say, okay, and wire this thing out too. And so you'll have some of those photos, you can kind of see there's like a piece of equipment and it's got a bunch of like wires sticking out of it. And you're sort of, you have like alarms, power, ground, different functions of each piece of equipment. And the more you stay and work there, the more you learn all these intricacies and so like an overview would be a schematic. And then you break it down and you get down to the wiring, and that's kind of the nuts and bolts of the job. And so I guess I just wanted to show you on here, kind of like, we make these cram racks, which are these photos, and they stand about, I don't know, 8 feet tall, and they're from floor to ceiling, side to side, front and back. They're just loaded with equipment and wires and terminal blocks, which are kind of like adult Legos. And I brought a couple of them. We draw with microstation, which is a complete oddball, unfortunately. And it's pretty compatible with AutoCAD. People that are AutoCAD folks that really understand it. So this kind of equipment, you know, it has all these wiring inputs, and all of these terminal blocks are kind of in a row along the cram rack. So the cram rack has rows of terminal blocks on each side. And then we use these things called equipment locators. So each one of these pieces of equipment gets a number that corresponds to it. So this is the front of the rear of the rack. And this equipment would be, you know, so this would be 1J, and you would find that. And then rather than like, if you wanted to connect this to this, like if you were working on breadboards or whatever, you would draw a wire or you would draw a line. That became really complicated because all of these lines would cross each other and stuff. And so they came up with this really cool system of wiring where if you're at 3X, which would be down here at the bottom of the rack, and you want a wire to go to 5E, you would just go 5E01. So that wire it's called point to point. So it points to that. And then this wire on 01 would point to 3X05. So that would be, this terminal would be 5. So you point back and forth, and then you point to terminal blocks, and you'll see on those terminal blocks, they all have a number on them. So each one of these terminal blocks is numbered down there. So you can point from 3X to a terminal block. And without drawing the actual wire in there, you point to that terminal block. So it'd be T008. And then from T008, you'd also go back to 3X08. And I guess why I'm telling you this stuff is if you get into the interview at Bonneville, this is going to be something that you're going to want to at least have a warm fuzzy of, because it's kind of the nut and bolt of how we wire out these huge rack systems. And a lot of times the schematic is an overview of this, but these terminal blocks and these wiring pointing at each other is how the whole thing works. And I mean, at first it was a little complicated, but once you figured it out, you're like, wow, this is really smart. Because if you've ever tried, I'm sure you're trying to draw circuit paths and stuff, and the wires are crossing, and you're kind of like building a loop over it or a bridge and trying to show all that stuff on a drawing. It's really difficult. So this system works really well. And yeah, we pretty much load these things up, and so it gets really complicated. And then unfortunately, you never really, once you finish a drawing, you don't really get to work on it after that. Like it goes to a whole switchboard shop that they do all the wiring. And so if you're hoping to do like hands-on work, it's kind of, there's a lot of different fields, like John mentioned was, there's electricians, craftsmen, linemen, engineers, and because it's the government, it's very segregated. It's not like, oh, I'm just gonna walk over here and like grab a screwdriver and start screwing down a wire on this lug. That just, yeah. That never, yeah, that never goes, that never happens, and it's definitely a big no-no, and it's like, so there's all these craft boundaries. And it's kind of unfortunate, because I'm more of a hands-on kind of person, like learning, like if I was wiring out a rack and I was like actually landing the wires, I think I would have a lot more of a sort of hands-on feel to it. Whereas I kind of wire it out and I'm kind of like rolling the dice and making sure that it, like, oh, I hope that went right, because the switchover shop will call you and they're kind of like, I don't know if they're grumpy would be a good word, but they get frustrated with mistakes and these numbers pointing back at each other, it's pretty easy to get a typo. So you can, get a couple typos on a big job and it's not a big deal, but once there's a big amount of typos, then they'll throw the whole thing back at you and you have to start over, and it's really embarrassing. And it's not like you're gonna get fired, but it doesn't look good, yeah, I don't know. The kind of craft boundaries that John mentioned are really, they're really cool. Like from, if you got in the door of Bonneville, like you can apply for an electrician position, which is like a 5-year apprentice program, lineman program, all these different programs, and they'll pay you to go through these classes to learn. And same with engineering. I think we still have a student program. Yeah. And so there's all these ways to get in and sort of learn more, get better, learn more, get better. And the craftsman position, I'm not exactly sure what you're studying, but for me, it's always been sort of the holy grail, like, because all the stuff I do is on paper and a CAD machine in a cubicle, right? But these guys are like out in the field, they're driving around a 5-state, power system, and they're fixing things at 2 in the morning if they need to. And they're really sharp people, and they're really, really technically on it. And I don't know, they get paid a lot of money. And I think they're really well respected in the community, because they take these, paper drawings and read them and make the stuff work and keep the lights on and keep it all functioning. And it's really pretty powerful. So like, there are a lot of options once you get hired. At the time when I was at Mount Hood Community College, the program was non-accredited, so there wasn't really any way to go up higher than like to go back and start over, basically. And so I felt pretty comfortable being at Mount Hood or coming from Mount Hood and coming into there. It was like really nice environment. It's like very I don't know, people don't really judge you by the way you look or your race or color or any of that. I mean, it's really more how hardworking you are and how much of how much you put into it. And that's what people respect. And so it's a very comfortable place to work. And I don't know, I just got kind of pacified and I was kind of in the pay scale pretty much equal to an engineer, which I'm working with or for an engineer, but it's pretty much the same pay scale. And so up until a couple of years ago, when they got like a 30% raise, I was like, oh, why would I take on all this responsibility? Be the one who's got their finger, someone's pointing the finger at them, like, what went wrong here, So it was very comfortable. And then, I don't know, 25 years went by and it was pretty easy to stay as a technician. But to say that it's not a dead-end job, I mean, you have a lot of opportunities to move up and move around in there. So, I don't know. See if there's anything else. You think of anything else?
What kind of education is it across?
A lot of them are ex-Navy. So electronic schools, 2-year schools, some of them probably none. But they have a pretty amazing training program where they get into, there's 2 routes.
You have an in-house training?
Yeah. A lot of them are in the military, but, so the 2 routes are kind of high voltage and low voltage. The low voltage would be so we'll get a lot of radar techs from the Navy. A lot of people that study communications in school. And then on the other side, it's sort of the high voltage side, so we're looking for like, the big one is protective relaying. So with all the programming, like you said, the smart people that go out, put that stuff back together in the middle of the night, the flashlight. If a tree falls into a line and or a transformer blew up, I think. Just down the road, what's the station right down the road by the Tropical. Yeah, so we had a transformer below that Tropical, and this guy's go out in the middle of the night, put it back together without prints. We come in later and try to build the prints that would be needed to work on it next time, but those guys, they are amazing. I worked in what's called commissioning for about 8 years, which is out with those guys, kind of building and testing things that are in construction. But like you said, there's so many different routes you can take once you get in the door. You want to travel to Northwest, that's where the money is, and that's where you learn a lot. I worked at a bank when I was in school at Clark, and I remember a guy came in and cashed a check, and I said, "You don't mind me asking, what do you do?" It was a huge patient. This was in like 2001, and it was like $5,000 or $6,000 for a week. He's like, "Oh, I'm a lineman for BPA." Oh, I guess he was. Something about hanging out of a helicopter above the Columbia River. Not my cup of tea. But yeah, there's a million different options. Said you can stay in the office and do design, planning. You can go out and do operations and maintenance. You can do commissioning, testing, construction. There's a lot of different options.
Yeah, the communications one, I mean, I think it meets the rest of the world. It crosses over really easy. I mean, like Verizon, all these telephone companies and stuff, they would love to get a BPA, PSC person, comm person out, pull them out and, put them into that industry, because it's, they just need so many people, and there isn't really that kind of training where you're hands-on like that.
Military.
Yeah.
You can set up
Military.
a comm center while you're getting shot at. You can work on a substation.
Right. Yeah, so do you folks have any questions? Like,
Yeah, just as someone who's thought about different options, let's say you wanted to do a 2-year education, enter into BPA, and then at some point you want to go like back into a 4-year pipeline, right? What sort of part-time education opportunities are available to that? Like a class at night at a term, kind of like what you can do in the BPA helps out, or is there actually time a lot of years?
There are options. I'll say there aren't a lot of options for paying for school. And that goes back to the fact that we're spending taxpayer dollars. We don't even get coffee. We're very frugal. But there are programs, you could join the student program, and they would pay for all of it and pay you for the work while you work through school. So that's one big one. As far as like tuition reimbursements, I think you can negotiate that as part of the job up front, which we are doing right now, because it's hard to find people to work right now. We're paying moving expenses, we're paying bonuses. I mean, we get very small bonuses, 3, 4, 5% is good. We're getting 10% retention bonuses to people every year just to stay. And they're also negotiating tuition reimbursement for that too. So right now is a good time to negotiate that kind of stuff.
yeah, I mean, for me, there was an opportunity where I could have switched over and started an engineering program. But when I initially got hired at BPA, I hadn't finished my degree completely, like a 2-year AA degree in electronic technology. But I was going back and finishing like a bunch of, I don't know, it's like math and English and courses that I just kind of pushed away because I didn't want to flog my studies because with all this kind of stuff. And so I hadn't quite finished, and BPA did pay for all those. and I took them at night after work just to finish up the degree. And it was just a handful of classes, but they did pay for those. And I think those are somewhat negotiable. Like, it seems like you can ask your boss and they'll approve some courses, especially if they're related like that, you know. But yeah, like John said, there's a ton of in-house training that goes on too. So you're weekly, or probably monthly, we're getting training from other engineers and all of us sort of group up and we get a training that way. And so, you know, if you're really into it, you will definitely learn a lot, and people will see that, and you'll definitely get noticed and you'll get moved up, you know. The other courses that I like, the electrician program and the lineman program and the substation operator program, all those have their own like avenue to where you apply to them. And I don't know so much that it would help if you were already a BPA, but I kind of feel like it would. I don't know. Yeah. And yeah, no, it's a big workforce, so there's a lot of avenues, and you know, I don't know, as someone who's loves the outdoors and that kind of thing, it was really hard and confining to go into a cube for that many years. And but for someone that is like okay with that and likes a clean work environment, and it's like knows what they have to do every day and knows where they're going to commute to every day, and not have to drive to Idaho, you know, in the middle of the night. Like there's pros and cons to both sides. I mean, I probably should have been one of the guys driving out in the middle of the night, honestly. But at the end of the day, you know, you get out of work and you don't have like a big cloud of, you know, like right now you have probably a bunch of stuff in your head when you get out of school that you have to work on that night. You don't have that. You just, you know, I mean, things may come to you, but you're not like, I guess you're not required to work outside of core hours. Like it's, you leave your job and you come back the next day. No one's going to be like, you know, did you spend 4 hours on this last night? Like, no, like it's over when it's over, which is a really nice feeling, because you know, with the time off and the flexibility and the work schedule, you can, you know, just go
So
take a
all
3
these
day.
things there, that's super rare. In the engineering, that is very, very rare. Because whatever you're working on has some kind of critical path outside of BPA. And if it's not meeting that critical path, you are either still at work, getting it there, or you're worried about it. Just thought I'd toss that out.
No, thanks. Yeah.
We interview a lot of people from, like, Intel is a big one, just because they're so close. And we interview a lot of people from Intel. I don't want to put anybody down, but they work, you know, 60 hours a week. They get paid a lot. They get paid a lot. But by the time they come to us, they're just like so happy to find a place that kind of values that work-life balance. We don't work overtime to all. I did work out in industry. I worked for a couple companies where that person who comes in early and stays later, we don't get a bonus, you don't get to keep your job. And we just we're not a profit company. We're not making a profit. We're kind of government. So it's more important for us to put out a product that's safe, reliable, and I guess safety and reliability is the biggest one, but it's never that my boss wants this done, I better get it, you know, on their desk by Monday morning, at that. It's, if you're late, if you screw up, we don't really care too much about that. Is it safe? Is it reliable? Can we build it? Is anybody gonna get hurt? Those are the big things. We're not competing with another company. We don't have to beat anyone in the market. And so that comes out in our 4 hours. So we're not competing. Very, very low.
What's the Army Corps of Engineers news with you? Like,
So they
can't ever
own,
figure out like
they own the facilities.
they own them.
They own Bonneville Dam, they own all the dams all the way up to the Snake and the Columbia.
Okay.
But they can't transport any of that generation. We're the only person that can transport. So we do have a monopoly. So do they, but we work together. So by the time it gets down to PGE or Clark Public Utilities, we bring it to them from Arkansas. And they're a nonprofit too, or not for profit. You know, they're a little bit more government than we are, a little bit more, I don't know, I guess your typical government employee. I won't say anything. They're a little bit more typical government employees. Since we make our own money, we aren't dependent on the budget getting passed to get our dollars like other agencies are. Ours is coming from the work that we do. So we operate a little bit more like an actual profit-based company, but we do interface with them a lot. Their stuff has to get through us to get to the utilities.
In short, I think they're underfunded.
Oh my gosh. They get halted every year when they don't pass a budget. They get furloughed, they send their people home. It's never happened.
Yeah. And they seem like overworked and underfunded. And the substations on their side are often like really archaic and like no one put the energy and the money that Bonneville has into our side. So it's, you know, I don't know if I've overstepped there, but it's.
You contract out any work from the substation?
Yeah.
Not a lot. More and more every
I
year.
worked for Peter Hewitt for a while. And I just remember, this was way back, like 98, something like that. I got thrown in one of the Hewitt trucks and we're gonna go look at substations because they were like, did a contract job.
Yeah.
I don't remember what it was, but I know we drove for like 3 days in the substation, like freaking everywhere.
Yeah,
Like,
they're.
reminded what was happening.
Yeah, we do a lot of that. We cannot increase our staff beyond certain allocations. Like right now, it's like 8,001 people. We augment that with 2,000 contractors, which are long-term contractors. Anything beyond that is contract. So like when the Obama money came out, as soon as in 2008, we were not ready to do, you know, $500 million worth of work. So we contracted all of it out, but we're still very much involved in it. Another company might be contracted to do a design. Tom and I are going to be watching the whole way. We're doing their work, making sure we're following our standards, making sure it's buildable, constructible, and we might be just involved in the construction too. So we've never really completely let them come in and do work. We pay them, but we're right there.
Can you tell me like, briefly, basically what a substation does?
They usually have a transformer in there, so, or one or two, and so 230 volts, 500 volts, so 500 volts come in, 230 goes, spreads out, you know, so you bring in higher power and you split it and you send it out on different lines. And that could go both ways, or it can go down to the utility grid that John mentioned, like for the General Electric. You know, we ship huge amounts of power, 500 kilovolts, and goes down to like 13.8, you know, and then down to your household. So it's like we ship big amounts of power to little smaller PUDs and identities that distribute it. And then we take in generation, so wind plants, solar, yeah, natural gas generation, the dams. So everything is mitigated. You know, the wind spins up at 2 in the morning, the dam turns off. You know, there's just crazy algorithms that some of us actually work on to make this all happen and make it safe and make it work. It's pretty vast. I mean, and we're not really building new power lines, so there's a lot of ways to layer power on top of each other, or, you know, if this generation cuts out, then, you know, a bunch of other stuff shifts around, so you find a different path, and that works on the fiber system too. Do a lot of that or mitigate.
So I've done 1,000 questions. If you got one, you better raise it. Do you ever foresee a time where we don't have?
Unfortunately, I don't think so.
We're gonna grow before we shrink. So this 2035, starting in California with gray data, that so much green energy had to come in California or come from California. Oregon and Washington have followed suit. We're closing coal plants in Montana. But we're also building up to the point where everyone can have a Tesla in their garage. We're not ready for that. If you're looking for a career that's gonna last a while, there's a lot of work to be done, infrastructure wise. I mean, the same can be said of decaying bridges all over. But this is one that needs a lot of work, and we need to find interesting and innovative ways to do, even the drawings he's talking about, the CAD drawings. We're drawing dots and squares and circles on paper. It might be electronic, but that's very similar to how we did it in the 1950s. You're looking for young people to come in who have studied in your awesome classes and can teach us how to use layering in CAD to show multiple states, or maybe a 3D layout of the drawings he's talking about. We need a lot of work there, innovating the way we do things, modernizing the way we do things. And there's a lot of work.
Any other questions? About energy storage, where's that go?
It's harder than it sounds.
Oh, it's super hard.
They've got some where they pump water up to the
Yeah.
top of a mountain.
Falls, that big old.
I don't know. I don't think battery storage is.
Tesla packs on every house.
Yeah, I think what I would see happening before that would be distributed generation, which we're already seeing with people putting in.
Yep.
Or with solar, there's a lot there, but from what I understand, and this is just my opinion, a lot of people do that for the tax write-off, and the tax write-offs go away. You see, major slowdown in the build out. Same was true of the wind farms. But when California pulled the plug on building in Oregon and Washington, we saw a lot of the plans, wind farms, stop and go away because it was waiting for with all these agreements we make, interconnection requests. We had a mile-long list of interconnection requests, and when that legislation passed, they all went away. So I don't know what's happening with battery storage, but we're waiting.
It's unusual that the current energy technology is not fit for the current renewable energy production method isn't quite there yet to supplant.
It is, just isn't enough of it. So it comes down to how quickly they can ramp up and ramp. So hydroelectric, very quick. When there's a dip in frequency, when there's a major generation that just dropped off, let's say the Canadians lose a bunch of dams, one thing, right? And you lose, or food, or something like that. The other dams, all they have to do is like rotate the pitch of their spinning, we call it spinning reserve, the generators that are currently already spinning. So they can ramp up just by doing this. How do you ramp up? How do you ramp up solar? What if the outage happens in the middle of the night? You know when the wind doesn't blow? When it's hot and when it's cold. That's when we need it most. And solar helps with 50% of that. So it's not that it's not good enough, we just need more of it. It needs to be more distributed and it needs to be more balanced. And honestly, coal works really well. It doesn't ramp up very quickly, but once it gets going, it's stable. Yeah. A lot of arguments. These are just my opinions, by the way. Not an expert. It's getting there. It's unfortunate that I think we've deemed hydroelectric not. I mean, you can screw up and kill lots of salmon. Well, no. What if you need to work on something and it's right in the middle of salmon season? And then it comes down to something blowing up and you need an outage. That outage requires, reroute of power from one place to another. It can, we have to be very, very careful. What is that called? When you dump too much water and there's fish nearby, they get yeah, I can't remember what the element is. Nitrogen?
Yeah.
Increase of nitrogen. There's lots of.
Power like disappears. So you generate power and it's trying to transport it across to people's homes. How much power is lost trying to get from the generation power?
That was the toughest class I took in college. Fairly fast. What's that called again?
Losses.
My series?
ACDC fundamental stuff.
No, it was, like there's a power angle, which is like the difference between your voltage and current. And to sustain the electromagnetic field, you need so much what we call bars. So when you're power triangling down, bars, it's passive energy. Anyway, you lose a lot, but we have to have distributed bars support, which could be a static bar compensator, or usually it's in the form of capacitors. Series shunt caps, right? A shunt capacitor along is going to sustain that electric field, allow you to. But this is what happened in 1996 when the power went out. Anybody remember that? The rolling blackouts. That was caused by inadequate bar support. One of the hottest days of the year, when a couple of strategic lines in Idaho went down, which was another thing you guys are probably going to study, which is thermal expansion. So the lines get hot, they fan and they sag, and this is a really hot day, lots of air conditioning in California. There's one shared tree, tripped off one line, all those electrons find another route, does the same thing to those lines, and it's a cascading trip. Started in Idaho, went all the way to California. But yeah, that was same exact thing. That's the power calculation.
So yeah, they have capacitors and what are the Henrys? What do we get? Henrys,
Reactors.
reactors. So we have all those all over the system, and they're constantly bumping up the frequency or bringing it down and keeping it at one level. And it's
You wouldn't believe how much goes into just keeping the frequency at 60 hertz. From Canada to Mexico, with all this stuff happening, that's what these operators would take with us to just sit there and stare at the screen and maintain everything. Lots of stuff we build and put in service out in these substations that do all this quickly, like a remedial action scheme, we call it RAS. RAS came about, I think, six very smartly, you ever worked with Van Zandt, but brilliant engineer. And he put that together, came up with that, and it's this stability analysis tool that's sitting all over the place, just looking at voltage and current and all these angles across the system, and it can see instability building and spreading and arrest it very quickly. Very, very, all that RAS. Lots of it.
I've been to power lines before. You got a reason for why they buzz.
It's called Corona. And it's called Corona. When you exceed the, what would you call that? What are the words for that? The dielectric of the air around the conductor, due to the skin effect, electrons move to the outer skin, right? And then I'll sit there and hang out, and if there's any kind of floating or sharp objects, the electrons kind of fight for that spot. And if they get kicked off their spot, they get sent flying. If enough of that's happening at once. I only know that because it was an interview question. Yes. And I want to sweat, but I can't answer. I don't know that.
yeah, I actually wanted to bring interview questions to you folks so that you would have something in your arsenal, because there is some tricky ones. Not that tricky, of course, but. Did you have a question?
Yeah, I'm just curious about, the summer when the water levels in the river, they're super low, like, how did that affect?
So the dams on the Columbia can't hold much water. They're not like Grand Coulee where they flooded all that farmland long ago and converted it into what is it, the lake, but it's not really a lake. It's that one, water. Reservoir. The dams on the Columbia from Bonneville up to John Day, they're, what are they called? They're called run of the river. They can't hold a whole lot of water. So they have to let the water go. You can't really hold on. If water levels are low, we have treaties with you know, Native American tribes, we have treaties with Canada that dictate really how much we can do on Columbia. And there's a lot, I don't know the specifics, but there's a lot that goes into this. We have teams of lawyers that work with the tribes and Canada on this. And we also have to protect fish and wildlife. So I don't know the answer to your question, but I know they can't hold water. And it's, these treaties go back 100 years, what we can and can't do. It's really amazing. So, but, a lot of times we don't get to do what we want to do. That answers your question.
Our dam also feeds into Canada.
No, there's more dams on the Columbia than Canada.
Oh,
Columbia starts in Canada and comes down here, so we share it. I think I can't remember how many we got. And I always confuse the ones on the Columbia and the ones on the dam, or the ones on the Snake, but there's a whole bunch that they have more on there.
BC Hydro is huge,
Yeah.
huge amount of power for the North America.
We've exhausted your class.
I think we're good.
Yeah.
Any more questions?
Should be an email. You could provide them my email.
Yes.
I'll take all the emails you guys got. Things that you're looking for positions. I've worked in a handful of places in Ottawa. I can guide you. Even if it's not for substation design, is what we do.
yes, I kind of have a question about, I'm in the 2-year program now. I just started in the fall, so I got a ways to go, like logistically, what would that look like if I was interested?
You could look into the student employment now. I think that's on here. I can't remember. Yeah, pathways. So there's a couple different options for pathways. We hire recent grads and we hire current students where you continue, and I think we're the case for all of it. And the cool thing about that one is the day you graduate, you're guaranteed a job. You come in and you have a job.
So they haven't had. Walking to an industry with BPA, yes. A little question, are they might, so.
My questions are engineers, and I do like it. But
Absolutely.
we're looking for folks that have a CAD background and can maybe learn some design stuff. We'll teach you what you need to know. We don't expect people to know how to wire up a protection scheme program.
Is there a age requirement to apply?
I don't think so. I think we used to hire high schoolers. I don't think we do that anymore, but. Are you in Running Star?
Huh?
Are you in Running Star?
Yeah, it's called really college, middle college, yeah.
Is that a boarding guy?
Yeah.
Okay. We call it Running Star. Mark, but
It
anyway,
just means they're still actively.
I had a 16-year-old that helped me through.
They don't know where they're at, they're somewhere.
Gray area.
I don't know. I suppose you could apply and see, but I don't know that we have a restriction. You're a student, you're a student. You can have all of it.
Yeah, if you had a 2-year associate's degree from Mount Hood, you would definitely run a good chance of getting hired. I mean, especially right now. I mean, I worked with 15 technicians like myself, and we're down to 3. So
Right.
that's through
I
retirement.
need my students, so they need to keep going.
Yeah. Wait a minute.
You need a degree.
Yeah.
Good time lasts so long. Maybe BPA is too.
It's pretty good.
Where's your office?
We're in Vancouver, just off Hazeldale, so,
Okay.
yeah, the technical offices are there, and then we have sort of administrative stuff down at Lloyd Center.
Okay, I knew that.
How about forward?
I didn't.
Someone else?
So right now, we are, ever since COVID hit 3 years ago in March, we went to a 100% telework schedule. And then within the last 6 months or 8, we have to do 1 day a week in the office. So we're 4 days at home, 1 day in the office. And that also is flexible. You could do 2 days 1 week and 5 is working from home the next, and, you know, that's probably subject to change. You know, I think they would like to see us come back to the office, and, you know, I think there's a lot of people that would like to be back in the office, so there, it's kind of a mixed bag. I think there's a lot of retirees that are gonna be like, yeah, I kind of liked it at home. I'm not going back. So there's gonna be even more job opportunities for you folks. But yeah, it's been a really interesting 3 years.
Students do. Like,
Yeah.
There's a lot of students that are tired of being. Back. I was got used to being on the phone and that's really good. So yeah, it's the same.
Yeah, I didn't think our job actually would translate to telework because we're so hands-on with each other. Like someone hands me something, we talk about it for an hour. We go back and work on it, and then we come back and, you know, we look over it again, and now we just send PDFs around and we talk on phone and Skype and all these different tools, and there's some losses, you know, admittedly, but there's been a lot of flexibility too, so that has made the work-life, you know, balance just amazing, right? So, yeah. All right.
All right, thanks, guys.
Yeah.
We wanted to show more diversity. Like. We try, let's come once.
That's all for this. This is lab time. If you need to work in your teams, you can work in your teams. Use your time.
Basically. I believe we're.